So we are starting today's Codeforces contest. This is contest round 847, and this is Div 3. So this is the first problem. It might be simple, and that's about it. So you have been given t number of test cases, a string containing some n digits, and then you have to compare the string with the original, value of pi. Pi, you can just type pi up to 30 decimal places, right? So that you will need. Why you will need that? Because you have to compare the string which is up to 30 digits with something like pi, and you have to tell how many digits, how many first digits of the pi are basically same with this, right? So if you read the question, the overall logic will come out as, because he has stored some numbers. Okay, this number should like he has remembered pi and then write down some numbers. Now we have to check how many numbers he remember correctly, starting from the first digits he remember correctly. So you have to go from first, second, third, fourth, and so on. So how many numbers are actually matching with pi? So what I did for this is pretty straightforward. I can just show you code, I think, because yeah, this problem is not much to think about. So I store the value of pi in a string called a up to 30 decimal places, taken from here. Obviously, I don't remember. You should remember. Okay, and then string s you have, and you can put string s, and then you check how many initial digits are equal. S of I is equal to a of I, then I plus plus I starting from 0. It will break out when the two elements don't have same value. Otherwise, it will go up till 30. So you will return 30. So that's about it. It will return the index of that, how many values are equal. Yeah, it will return the length or index or whatever you can say. So when index is 0, the length is also 0. Yeah, because how many index are same? Two index are same means length is 2, valid length is 2. So that's what you need to return. So simple, basic one. This is the whole code. Our logic straightforward. Let's move to problem number B. It might be somewhat hmm, level up. Taisia and dice. Okay, so you have been given, this is the problem number 2. You have been given six-sided dice. Each face of die is marked with a number 1 to 6, right? Each face of dice is marked with a number 1 to 6, and basically what you are doing with this dice, you have been given a dice, right? And then t number of tests is a number nsr. What is n? N is basically the number of rolls which you are doing. You can think of it as like that. And s is basically the sum of the numbers which are appearing on the dice. So our numbers are 1 to 6. If you are doing n rolls, so number would be n into 6. So n is 50, so sum can be up to 300 at most. And r is basically such a number which is, after this rolls, there is some maximum value which you got during this n number of rolls. Let's say you got 5 as a maximum, or 4 as a maximum, or 3 as a maximum, right? It can be anything. It cannot exceed 6, obviously, because 6 is a so yeah, one dice with a maximum value ai 6 can appear, something like that. And then calculate the sum of the remaining elements. So before, like, excluding this number, what are the sum of the remaining elements that is stored in r? So you have n number of roles. Let's say n is number of roles you have, and s is the total sum you have, and r is something looking like, if you carefully say, it is total sum minus a max value. And now you need to print out the n numbers, a of n numbers, like a1, a2 up till an, the numbers which you might have rolled. Okay, so that you get these kind of scenario. And is basically not contributing in this, because n is just saying what is the size of the array. Total sum is telling you what is the size of the total sum of the total array. So you have the sum of a1 plus a2. So like a of n you have is equal to, let's say, you have s. And if this array is sorted, okay, you can think it is sorted. So if this is sorted, then all except, last. So what will be sum of all except last? One a1 plus a2. So like a of n minus 1 is equal to r. So this give you at least one number. So it give you right directly, it give you one number, which is a of n is equal to s minus r. So that's what I did. I say, like, okay, I got first number as a n is equal to s minus r. Okay, so just print out first number. And now you have to remaining n minus number you have to find, right? N minus 1 number. Fine. So the logic for this would be, the sum would be up till 6 into sum is lesser than or equal to 6 into n, right? It cannot go beyond that. So what I did, I calculated, okay, so r is also something like somewhere over here. Sum comma r is 6 up to l. Okay, I did r divided by the total number. So R is the total sum which I have currently. After printing this, I'm just taking this elements into consideration. Okay, a1 से लेके a n minus 1 I need to print, right? What is this? I don't know. I know an, I know, so I printed an because an is the difference between s and r. Now a1 to an minus 1 I don't know, but I know the sum, I know the total number of, yeah, numbers. So what I did, r divided by n minus 1 I did, right? R divided by n minus 1, it will give me, uh, somewhat value which is closer to every number. So I am saying ki, okay, let's say this is equal to x, and there would be some r modulo n minus 1. After dividing this, you will have some remainder equal to y. So what I did, I give every number x6, like let's say I give x n minus 1 times. So n minus 1 times, if I give x, so the total sum I have is equal to n minus 1 into x. In the very good case or best case, it can be just equal to x, your it can be just equal to r. So like when there is no remainder, y is 0. Otherwise there are some remainder, so there some would be x plus 1, x plus 1, there would be some expression, because y cannot increase, y cannot be greater than n minus 1. So among this n minus 1, there would be some pairs, there would be some indexes, some exactly like y number of index, which you can say is equal to x plus 1. So total value kitni hogi, x plus 1, like y into x plus 1 plus में and other would be just x. So other, what do I mean by other? Total was n minus 1. You removed minus y from here, and then you do into x, and then it is equal to, let's say I'm saying a1 से लेके an, right? This is a1 से लेके an, which is okay, certainly good, because that's how I did. And this is possible. I'm just want to, the only your doubt which should come to your mind, is this possible that r upon r minus 1 I'm getting a number x, this number can be greater than 6 also, this can be greater than 6, or this number can be 8 or 9. But that's not possible, because r is up till 6 into n. Okay, it's lesser than 6 into n, so it would be lesser than 6 into n minus 1 also, I think. Yeah. um hmm, r is less than 6 into n. So n numbers if I'm giving, so at most they can be all 666, but they cannot be all 666, because if there was if all were 666, then maximum would also be 666. So they cannot be 5, and they cannot be up till let's say maximum one is 6, then the remaining sum is equal to, you can say key 6 into n minus 1, then all can be 6. Okay, if maximum is 5, then all will be 5 and just, right? So in that case it's just 5 and, so this number is guaranteed, this x will come out, will be lesser than 6. Okay, will be lesser than 6, exactly lesser than 6, will be lesser than 6. It would be something like 5 or something like that. So, or 4 or 3, and x plus 1 is also in the range. So this is the surety which you should have. And otherwise the only thing is very simple, like because this is the total device, and this is remainder. So that's how I did. If I have to show the logic, should I code it? I think I can code it pretty fast. And yeah, it's, you should see the code. And t c and t minus minus int n. And what I did, I what I have NSR. I have NSR. I don't think I need to code it, because I just explained. So let me just write some kind of a pseudo code. First number would be S minus R. No one can, uh, yeah, skip that. So value one, I'm saying key R divided by, let's say, n minus 1. And value 2 would be r modulo n minus 1, whatever remainder that you got. So what I'm saying key, for int I is equal to 0, select I is less than v2. So for v2 numbers, what you have to print, you have to print v1 plus 1, right? And for all other number you have to print, like for every other number, int I is equal to, how many numbers are remaining, can you tell me? V2 is filled over here, 1 is filled over here, so v2 plus 1 is already been filled. So you can start from index v2 plus 1 and go till index n minus 1 I plus plus, and see out your v1. I think that should be enough of it, and then see out endl. So It was also a very simple question, so no need of this also doing this. But yeah, I've done this now. Okay, you can check it. 1 1, right? 2 2, 1 2 2 4 6. Then the exact numbers won't be same, but the sum and maximum number would be same. So maximum number is 6, and sum also you can see key 2 is same, 6 is same. 2 4 3, instead of that I made 3 3. That's good. All ones, and 3 5 over here, 3 4. But that 3 number goes into, like, let's say there was a 4. Okay, so there is a 5. Yeah, that 3 number goes into 1. Okay, so this is looking fine. Let me try to sum this up. My original summation is also like somewhat like this, but somewhere slightly different, so it will get accepted. Yeah, so that, as we can see. Okay, oh, okay, very fast, very fast. Okay, accepted. Yeah, so let's move to problem number C. I think that was also easy question. Should I just hmm. Okay, this was a pretty decent question. Okay, this was pretty decent question. They have updated tags. How fast they are moving today. Okay, so I'm just waiting for the yeah, rating of the problem also. But you have been given t number of test cases, a number, and you have been given a matrix, you can say, of size n cross, not n cross, but n, yeah, n cross n minus 1.
नहीं मैं आ रही हूँ हाँ अरे पता नहीं खाई जाएगी या नहीं बना दो
Yeah, so what I'm saying, okay, 12 minutes, okay. So you have been given a matrix of size n cross n minus 1, and what does this represent? So this represent that you had a permutation, you removed one of the digits. Okay, so between n digits, anyone you can remove, right? So when you removed first digit, you write the permutation, it would look something like this, not like exact order, but after removing one of the digits from each of the permutation, the remaining numbers would be 3, and these 3 numbers are given over here in they are not in order. Like, it's not like that 4 2 1. This has come out after removing 3, after removing the last index. 3 4 2 3 4 2 3. This has come out after removing the third index. So let me just directly walk towards the logic of this problem. Observation based problem. Observation is to see in this column how many 4 are appearing, right? In this, how many numbers, how, yeah, in this particular column, what is the frequency of each number of 1 2 3 4? It's not like you have to see the max frequency, that would be the answer for that column. No, you have to see there is a specific value that this number has to be present exactly this many times in this column and these many times in this I plus 1 column, then you have to tell the answer. So actually, if I show the code, code is actually long, but logic is pretty much simple. So let me try to explain the logic with some of the test cases. Let's see. Code is also not tough. It's really easy. It's just long, or maybe I will write code. I don't know. But first, let's talk about the logic, which is more important. I already gave the glimpse about it. So this is 4, which means, okay, what they are asking, they are asking that yeah, they have been given a permutation, right? Initially they have been given a permutation of number n, size n. Okay, permutation of size n, 1 to n, yeah, they have been given. After that, they said that we removed one of the digits from the permutation. So let's say permutation was, okay, let's take the original answer for this. This would look like 4, look like 2, this would look like I think 1, and then it would look like 3. Yeah, 4213 is his answer. 4213, yeah, that's the answer. So they said that after removing, let's say 3, I got permutation like 421. It's not a permutation. It's okay. it was a permutation, I removed one of the digits. This one of the digits can be anything. It can be like, let's say 1, or it can be, let's say 4, or it can be, let's say 3. If I remove 4, it will become 213. So I'll write 213. And if I don't change 4, if I change 3, it will become 4 to 1. So there is 4 to 1, and so on. There are impossibility after changing n numbers. Okay, so these possibilities are written over here. You need to form the actual permutation looking at this, just by saying, like, key, okay, I removed one of this and I did not change the relative ordering. So 413 relative ordering is not changed. This means like 2 has been removed from this place, and now it looks something like this. So how will you get the answer? So this is the first observation about this problem, like why this 4 is occurring so many times in the first place, and why 3 is occurring so many times in the last place. Because this is the because of reason, because when you change 4, only then 4 will not come at the first, otherwise it will always come out the first. So when you change 4, for that case 2 will come out, of whatever is present at the second index will be on the first index when you change 4, when you change the first index. Okay, otherwise if you change any other index, you change 1, 4 doesn't matter, 4 doesn't care. If you change 2, 4 doesn't care, 4 has to come in the first, right? If you change 3 also, 4 doesn't care, 4 will come on the first. So for this three cases, so there is a number associated with this, every number. So if first row there is a number which is repeating n minus 1 time, that's the answer for that one, right? But it's not simple for every column, right? It's not simple for every column. That's why the observation becomes somewhat trickier. Let's see for the second column. You will get the thing. Now 2 is occurring two times, 1 is occurring one time. Now what should be the answer? We'll not look at this column table now, given table. We'll try to find, okay, we have to look at, but we'll just try to say with guarantee that this has to be the answer for that column. Like in this first column, I can guarantee that 4 is my first column because it's occurring n minus 1 time. Okay, so this is the first logic observation which you can figure out after seeing multiple example. Now let me just directly walk into how many times the number should be present, so that I can directly say that it is the element of my second column. So if you see correct, if you carefully see second column, so this is the second column, this is the position of second column. How many numbers are there on the left side? One. How many numbers are there on the right side? There are two numbers. So when I remove, let's say this number, when I remove, let's say there are three numbers except this two. Okay, so let's focus on these three numbers. So if I remove someone from the right hand side, if I remove 3, 2 doesn't 2 says, okay, I'm coming on the second place, I will come on the second place. 2 doesn't care, you can say something like that. And even if you remove 1, 2 doesn't care because 2's position was 2, is occurring on the 2. So what I'm saying ki any number which is occurring, how many times, like if there is written 2 over here, 2 times in the second column. Okay, and how many times in the first column? If you change this, there is only one element, right? So if there is an element which is occurring one time in the first column, right? So I should write it like this. If it's occurring one time on the first column and two time on the second column, that would be the answer for my second columns. That's what I can say. Now similarly, you can just say over here somewhat who is occurring two times in this and three times in this. No, one time in this. Why? For that also you have to see 4, 2, 3, 1. What would be the value of my third column? I don't know, but I know like how many times this is occurring in this row. So what I'm saying, key 3, for the third thing, there is one element on this side and two elements on this side. So if I change any one of them, so its position will change and it will come one unit backwards. So when I remove, let's say for how many numbers, for r, for numbers appearing on the left side. So this was the number appearing on the left side, this was number appearing on the right side. Okay, so L was equal to, let's say, what is L? I know L is equal to I minus 1. No, not equal to I minus 1. It's I, because if my index is 1, which means if I talk about zero indexing, index is 1, the element is 2. How many index are on the left side? 1 only. And how many elements on the right side? It will be n minus 1 minus I. So that is the whole logic about this problem. So you have to see for the third column, any number which is occurring in the ith column, how many times I times, I think, yeah. At L side, how many numbers are there? See, two numbers are there on the L side. So I'm saying ki any number which is occurring two times in I column. Okay, in ith column. who is occurring two times. Why two times? Because index is 2, his index is 2. He has to occur on the hmm, he has to occur on the first index. Okay, so on the left side there is only one element, which means yeah, now on the left side there are two elements. So I am saying that in this column, like while checking this column, let's say while checking this column, let's say column number C, I need to find out which number is such that it appears, like say hmm, C times in this, and n minus 1 minus C times in this, I think. Yeah, one time in this, which means n minus 1, which is 3 minus C, which is 2, right? So yeah, one time in this. Yeah, that's the answer. So for Cth column, okay, so this is the logic about this problem. We'll verify it using the second. This was observation based. Yeah, for C column, answer would be the number appearing C times in previous C minus 1th column. ठीक है? Minus C times in Cth column, right? This is your answer, man. This is actually your answer, because if you're talking about index C, if we are next talking about index 2, so there are two elements on this side. So there would be two occurrences when I remove any one of them. When I remove 2, or if I remove 4, then at 2 time he will come on the C minus 1th column, because one element is removing from the left side, its index will be decremented by 1 unit. So that's what I'm saying. C minus 1th column में how many occurrences there? uh, C occurrence are there, because even if any of the element from the left side, which is a total number of C elements, you remove, so it will occur in the C minus 1th column. ठीक है? C times in C minus 1th column, and the remaining times, like how many times are remaining? N minus 1 minus C, like, because there are total n elements in this permutation, and out of that two elements on the left side, this is a current element, remaining element is basically on the right side, right element is just one in this case. So it will appear only one time in the current column, like which say 3. When you remove one, then it is saying that I am not affected. I am the Cth column. I will appear in the Cth column, but only for the right elements. Right side element is this. ठीक है? या फिर you can just say it like, now you got the idea. You can just say it like right elements. That is number of right elements. So this is all logic about this problem. You have to see for a current column. For a current column, which number is occurring I times, and which number is occurring n minus 1 minus I times. That's what you need to see. Should I code it? थोड़ा सा पढ़ा है, So video will go long, so let me just show you code, because uh, yeah, that's not, I tried to make it okay. So let me code it, yeah. Let me just test my speed thoda sa, right? So int n in vector of vector. This is to take input, right? If you see carefully, n rows and n minus 1 columns are there in input. 0 you can initialize or cannot. Now there is a final matrix which you will not final matrix. This is a column matrix which you will need to see how many times a particular element appears in a particular column. So first of all, like, let's do what he says. Like, let's take what input says. J equal to 0, j is less than n minus 1 number of columns are there, and scene of v of I comma j. So this is the input about the this. Now I'm saying ki we need a matrix. You can have a map, you can have any storage like that, which gives you what? The which does something like this. So for ith row, not for ith column, sorry. For ith column, there is an array which stores AI stores is equal to occurrence of AI plus one element, like AI plus one in ith column, right? Sorry. A of j, you can keep it as A of j plus 1 to not get confused in this. So in every row, I want what is the frequency of 1, what is the frequency of 2, what is the frequency of 3, how I'll do this. So total number of basically you can see columns now I need is n. I need frequency of 1, 2, 3, 4 in just one row. So row is decreased by n minus 1. Why row is decreased by n minus 1? Can you tell me? Because the columns are n minus 1 in the given input, right? Vector of int of now columns has increased, row has decreased, n or 0, whatever you can do. Yeah, this is important to initialize with 0, because what I'm going to do over here is f of which column is it. I'm currently standing in jth column. I know what element frequency you are increasing. The element value is v of I comma j, and minus 1 you have to do plus plus, or you could have just hmm, done minus 1 over here. Why I am doing minus 1, you know now, because 1 2 3 4 indexing is 0 1 2 3. So this is all what I wanted from the input. I did not wanted this v vector, I just wanted this f vector, or this is final vector, answer vector, result vector, very important vector over here, which is giving you the frequency of the particular element in particular column. That's what I wanted. So for every column I will run. So for first column, this is pretty simple, like you don't have to let's say for int I equal to 0, I is the total columns. How many columns are there? N minus 1, I plus plus. You will see that here also I run for n minus 1 columns, but I think now you should run for uh, n columns, because f of n minus 2. Hmm. I don't know why I did not printed that, but let's see. So this is me going over the F matrix for the particular column. I'm checking in this particular column how many which element occurs. How I don't need to see like how many times how many element occur, that I know. I know to see which element occur exactly these many number of time. So I'm checking possibility for each number from 1. How many times this number occurs. But we have stored it as 0 indexing, so we will make sure that we use 0 indexing, and then you can see like your original number is j plus 1. OG number is uh, j plus 1, but if you look carefully over here I did minus 1 to store it like that. So yeah, now I'll check if its frequency in the previous column, which is f of I minus 1 comma j, its frequency in the previous column has to be like how much, has to be equal to j, right? And does it have to be j? It has to be j plus 1, because frequency doesn't compromise, right? Yeah, if this is a element 2, it should occur in the previous column 2 times, so that's why you can say j plus 1. And yeah, this is the thing which you have to realize, like why okay, not j hmm interesting. 1 to n minus 1. Yeah, for this column I am looking answer for ith column. Let's say I'm looking answer for, yes, ith column. For the first column I will be saying that okay, give me that number which is occurring n minus 1 times in the current row, right, in the current column. F of I comma j, in this current f of I, which is which element j is occurring, is equal to n minus 1 minus j. So initially it would be n minus 1 minus I, right? and that would be just I, okay, which is occurring I times over there and I minus 1 times over here. So now there is a good thing like um hmm, this you only have to do if I is obviously greater than this. So this is a basic thing. This is a basic funda for everyone. But there are two special cases for first and last. I don't think for last there is a special case, but for the first there is special case I equal to 0 and only this is happening and this is happening. See out what? See out that particular number that is j and not j plus 1 as I told you. And what you have to do, break or continue? You have to continue, I think. Don't go for this. For the next number, break. Now I will run for what? 0 to n. Which number is having frequency? How much? I'm looking for frequency 1 in which. So in cth column, in first column, the frequency should be 1. Okay. So this is column number. You can also like make good variable name like column number and equal to that column, right? So in this column, its frequency should be this. No, in previous column, its frequency should be like I. In the current column, its frequency should be J. So you can just take it this and just break out that. I did go to or I did what? I did like required is equal to J and then. Okay, so this is also the thing that there will be only one such element. So that's why I just stored in required variable and then printed that. You can do like this way also. See out and then this break. Now let's see for the last one how it will be forming. So for the last one, let's see you have this 1 and 3 has frequency 3, 1 has frequency 1. So he will go for uh, I is equal to, let's say, okay, now I'm going for the nth index. Yeah, for nth index you just need to see, yeah, I think, yeah, you can just go for n, and if this is n minus 1 and you just need to see previous one, I minus 1 comma 1 j is equal to I, then see out j plus 1 and then break. Yeah, that's about it. That's about it. Hmm. Break conditions all over. So but yeah, that is all. That should be all. Yeah, let's try to just print after using endl. More concise it is looking. Let's run for the first case. Oh man, video got too long. Oh, vector is not defined. Very good. Slash stdc plus plus dot h. What answer should be 4213. So the logic for this problem I'm again repeating was just to see how many times a particular number should occur in the particular column. That you have to feel about observation like I and n minus 1 minus I. Okay, where it's failing. 0 to n you have to go. Is there problem over here or where? Should not be problem over this side. So problem in this only. J is going from 0 to n. Should J go from 1 to n? 1 to n I cannot. Or maybe you can if you do it like this, or if you do it like let's see. What I'm saying ki if you do it like this, This is n minus 1 for the number of columns, which is obviously n minus 1. It's not increasing from them, but the value I'm storing, right? So can I just store value like this? J is from 1 to n. Can this j be my answer if the frequency of this j is equal to this n minus 1 minus I? N minus 1 minus I, and I made it over here there like current is equal to f of I, previous is equal to f of I minus 1, f of I, and this is the main thing now, f of I and f of I minus 1, and then j is obviously was okay, j was from 1 to n minus 1. You can have j equal to 1 to n. I is equal to n minus 1, I n minus 2, and j is equal to as from 1 to n. But then you don't need to do j plus 1. Now that is also the thing where it is failing, yaar. Don't move from your logic, which is 0 and less than n. So if it is 0 and I is equal to 0, you don't need to see for previous thing, right? So that's what I did over here. For 0, you just need to see the current I is equal to n minus 1 minus 0, which is n minus 1. Then you could just say CRJ plus 1 f of I comma j. 4 1. It should give the first and the last number. What it is giving, man? 2 3 2 5. I don't know. Now there is issue that you have to do it n minus 1 only. N minus 1 and okay, 4 1 4 1 2. It's printing first as good. It should print last also as good. 4 3 1 3 4 5 1 4 2 3. Fine. Then what's the problem over here? I minus 1 at the end. Okay, it should not run for that. So I is equal to 0 is going into that and breaking it. I is equal to n minus 1. Then it's and this, yeah. Yeah, there's problem in this line. How there can be the problem in this line? If I minus 1 comma j, right? I minus 1 comma j should have printed like else if. But then what's the problem if I have used the break? There is no point of using else if kind of thing. So if previous of j is equal to I, right? Previous of j means f of I minus 1 comma j is equal to I, and of f of current of j is equal to n minus 1 minus I, and j would be up to 0 to n. That's not an issue. Hmm. Why do you need n? Total number of columns are 0 to n minus 1 only. Acha. In this current column, what's the value of j? What's the value of j? Okay, so that was the thing. 1, 2, n minus 1 I'm running I in that case. And why it's still giving it?
अरे खाना खा ले आयुष ठंडा हो जाएगा सारा
I don't know why it's happening, like, which is giving segmentation fault. Let's try to see exactly which is giving segmentation fault. Okay, so this is giving segmentation fault. But that's the thing, you have to go for n up to n. Again. So should I just say key from 1 till n you have to do of I minus 1 j is equal to I. That is the thing, man. That is the thing. How to? Okay, so I can put a condition, right? Yeah, 0 and n. Condition would be I is greater than 0 and n I is less than n minus 1. All fine. Now fine. And anything else what you want? Yeah, I think this is looking fine after a while. 2 and 3. Let's try to sum this up. Pretty long video, but yeah, C problem was actually it was nothing after just observation. So simple observation, yeah, you have to do simple observation. D and E problem are good. Let's try to cover them in the next video. I shouldn't have you know, because after having the logic of C there is no problem in the implementation. But yeah, that's about it. So D is very okay. Actually my code, if you see my code for D, it's pretty short. It's pretty short and concise, very short code as compared to C, right? Logic is also very simple, but this needs some time. Okay, try to figure it out and then we'll cover this soon. Okay, bye.